it. So gases. Okay, as I mentioned before, in gases, chapter gases ni kita observe the behaviors of gases, how they exert pressure, how can temperature change dia punya behavior, how temperature affects pressure, how pressure affects temperature and volume, and so on. So there are three properties here that we observe: temperature, pressure, and also volumes. If you include ideal gas, kita akan observe also the number of moles. Okay, that's why kita ada discuss the other day the ideal gas law, the ideal gas formula, which is PV equals to nRT. And also we've discussed that you do not need to memorize the Charles law formula, the Boyle's law formula, and the Gay-Lussac's law formula, because you can derive those formulas from PV equals to nRT. So basically, you just need to memorize PV equals to nRT. I've included this JPEG of this ideal gas law, PV equals to nRT in LMS. So you can LMS. So P is pressure, V is volume, N is the number of moles, R is a constant value. The value is 0.08206. The unit is liter ATM per mole Kelvin, and T is temperature. Okay, so in gases ni saya ada mention also last week masa kita discuss, kita mula start this chapter. Kita observe gases in two environment, two system, closed system and an open system. Okay, so when the system is closed maksudnya we fill gas into a closed container. Saya ambil this cawan, saya tutup, so inside this mug there is gas. Okay, these gases kalau betul-betul airtight, gas dalam cawan ni tak boleh keluar, and gas from the outside of the cawan cannot go inside. So if we increase the temperature, saya panaskan cawan ni dalam microwave for example, so the pressure inside this cawan will increase because the temperature, the increased temperature that is provided by the microwave akan bagi energy to the gas molecules in this cawan. And when molecules get energy, it will move faster. Sama lah as us, macam manusia. Bila kita dapat energy, we have to use that energy. Bila kita ada tenaga, kita boleh buat kerja dengan lebih banyak. We move a lot more. We can move faster. So the same goes with gas molecules. When it gets energy, dia akan move faster, and when they move faster, dia akan bounce off the walls of this cawan, and the pressure inside this cawan, because it is closed, will increase. So that is how one example how temperature can increase the pressure of the gas in this cawan, given that this cawan is close lah, ada airtight lid dekat atasnya. Okay, so that's one example how temperature affect pressure. So kita mesti kita also observe ada some environments, certain environments pressure will be constant. Contohnya macam dekat permukaan bumi, okay, at sea level. Bila saya cakap sea level, dekat permukaan bumi lah. So the pressure around here, dalam rumah saya sekarang ni, dekat rumah kamu sekarang, dalam bilik kamu is 1 atm, 1 atmospheric pressure. So tak boleh berubah. Kalau kamu panaskan air dekat dalam dapur, yang berubah hanyalah the temperature of the gas of the water. Pressure tak berubah, volume berubah, because some of the liquid akan evaporate jadi water vapor. So hanya dua sahaja yang berubah, temperature and volume. Tetapi pressure tak berubah. Tetapi kalau contohnya kamu panjat gunung, okay, higher altitude, the higher you are from sea level, daripada permukaan bumi, the lower the pressure. Okay, because dekat atas or up there, tak banyak gas molecules, tak banyak benda. So less pressure will be exerted onto you. So that's why kalau kamu nak masak air, for example, if you want to boil water dekat on the top of a mountain, you will require a higher temperature because tidak ada tekanan. So kalau kamu boil water, kamu take a bowl of water, kamu panaskan dia dekat permukaan bumi, there will be air pressure, tekanan udara yang akan press the water vapor from escaping from liquid to vapor, okay, from liquid kepada gas. So that's why kamu perlukan 100 degrees Celsius to overcome that pressure. Tetapi on the top of a mountain, less pressure are exerted onto the water. Tak ada banyak tekanan yang menekan this water vapor from escaping its liquid form. So that's why kamu boleh didihkan air lower than 100 degree Celsius. Saya silap cakap tadi. Okay, so over the higher altitude you need less than 100 degree Celsius untuk didihkan air because tak ada tekanan udara. Alright, so with that in mind, let's discuss the quiz. Question number 1. A sample of chlorine gas. Okay, chlorine gas occupies a volume of 0.5 decimeter cubic dm cubic at a pressure of 1 atmosphere. So using Boyle's law, determine its volume if the pressure is reduced to 0.4 atm at a constant temperature. So here saya dah bagi all the values, all the details. What do I mean by all the values, all the details? Kamu tengok kat sini. Kita tahu gas yang kita, kalau kamu nak solve this problem, pernah saya nasihatkan kamu write down all the details that you know from the statement, from the question. So for example, kita tahu what kind of gas we have here. It's chlorine. The volume is 0.5 decimeter cubic. The atmosphere is 1 atm. So we know the volume and we know the pressure. V and P kita tahu. And then dia cakap kat sini, temperature is constant. Okay, so to solve this problem, dia cakap kat sini, Boyle's law. Okay, so it's easy already. You don't need to determine. Kamu tak usah payah nak tentukan formula apa, law apa yang kamu nak guna pakai untuk solve this problem. So apa yang dia suruh buat adalah determine its volume. Okay, cari isi padu if the pressure is reduced. Kalau tekanan dikurangkan kepada 0.4 atm. So from 1 atm, it is reduced to 0.4 atm. So Boyle's law, saya dah include dekat feedback box dekat bawah ni, kamu boleh tengok. P1 V1 equals to P2 V2. So you just fill in the values here. P1 is what? P1 is 1 atm. Pressure, initial pressure. 1 means initial, the values at the beginning of the process. And P2 is the pressure at the end of the change, at the end of the process. Okay, ada perubahan. Kita observe what happens if changes are made. So pressure P1 is 1 atm, V1 is 0.5 decimeter cubic. So equals to P2, P2 is 0.4 atm. So you determine V2. So jadikan V2 ni as your unknown, as your perkara rumus. So kamu bawa P2 ke bawah. Set. Let me buka whiteboard. I forgot to buka whiteboard. Whiteboard. Open the jam. Start a new whiteboard. Okay, once you know which formula kamu nak guna and you have all the details and kamu tahu apa kamu nak cari, you just fill in the blanks. Then from then on it's just basic math, basic algebra. Let me buka text box. P1 V1 equals to P1 V1 equals to P2 V2. Let me enlarge this box. Alright. So kita tahu nak kena cari P2. So jadikan P2 as your perkara rumus, as your unknown. Betul ke? What's the question? Sekejap. Determine the volume. Okay, kita nak cari volume. Kita nak cari volume, my bad. So V2 yang kita nak cari. Okay, the volume after changes has been made. What is the change? We reduce the pressure. So V2 equals to P1 V1, you take the values on the left hand side. P1 V1 divide by P2. P2 from the right hand side kita bawa ke belah kiri. So P2. So jadi so the answer is where is it? Where's the tab? Okay. So P1 V1 0.5 decimeter cubic darab dengan 1 ATM jadilah 0.5 bahagi dengan 0.4. So 0.5 bagi 0.4 kamu akan dapat 1.25 dm cubic. So don't forget the unit. Dia suruh cari volume. So unit untuk volume dekat sini adalah dm cubic, dm kuasa 3 ni. Okay, so kamu dah, bila kamu buat calculations, remember to include kalau kamu buat macam jawab soalan essay, if you write down the calculations, kamu buat jalan kerja, don't forget to write down the unit. Okay, so kalau kamu tak write down the unit, it's not a correct answer, it's not accurate. So saya nak kamu biasakan diri tulis unit masa buat jalan kerja. So the answer here is 1.25 decimeter cubic. Alright, so moving on, next question. The pressure of nitrogen gas in a food can is 1.5 atm at 35 degrees Celsius. So using Gay-Lussac's law, determine the pressure of the nitrogen if the can is heated to 40 degrees Celsius. So kamu ada satu tin, makanan dalam tin, dalam dia ada nitrogen gas. So the pressure is 1.5 atm dalam can tu, dalam tin tu. Temperature-nya 35 darjah Celsius. Katakanlah kalau the can is heated to 40 degrees Celsius, kamu letak atas dapur, panaskan dia to 40 degrees Celsius. So what is the pressure now inside the can? So this is the same as example yang saya bagi tadi lah, cawan yang masukkan dalam microwave tadi. So this is a closed system. Why? Because the can is sealed off. Okay, it is closed. Gas from outside cannot go into the can, and gas inside the can cannot go out unless the pressure is too much and the tin meletup. Alright, so to solve this problem, saya dah bagi kat sini using Gay-Lussac's law. So, saya lupa nak elaborate tadi. Macam mana nak, kalau kamu tak hafal Gay-Lussac's law, for example, saya dah cakap, saya dah include the video in LMS, you can derive the law from P1 V1 PV equals to nRT, the ideal gas law. So you must remember here, macam mana kamu nak tahu how to derive, kamu mesti cari apa yang constant kat sini. Okay, so kita tahu temperature berubah from 35 kita increase to 40, dan kita tahu pressure akan berubah because kita dah kat sini they increase the temperature and they suruh determine the pressure. So that means it is implied that the pressure is also change. So yang constant kat sini adalah volume. So the volume is constant. So untuk derive the formula, oh my bad, where's the whiteboard? Okay, so to derive the formula, you just write down PV equals to nRT. So the trick is you must move the values yang tak constant to the left hand side. Okay, so kita dah establish tadi yang constant adalah pressure. Can I change the color here? Yang constant adalah, okay, no. Nope, it doesn't work like that. So yang constant adalah pressure and also, yang berubah adalah pressure and temperature. So we need to bring temperature on the right hand side ni to the left hand side. So how do we do that? Kalau from the right hand side bawa ke belah kiri, kalau dia multiply kat sini, if you bring it to the left hand side, kamu akan letak dia dekat bawah, divide by T. And V is constant, so it needs to be on the right. Okay, everything yang constant duduk di belah kanan, everything yang tak constant, everything yang berubah duduk belah kiri. So NR divide by V, NR divide by V. So therefore that's your the first half of the Gay-Lussac's law is on the left hand side. So this is the first half of Gay-Lussac's law. So P1 divided by P1 equals to P2 divided by P2. See, no need to hafal. Saya pun tak hafal. So kita tahu from the questions tadi, pressure initially adalah 1.5, temperature adalah 35. So divide that. And then pressure P2 ialah apa yang disuruh cari. T2 is 40. So jadikan untuk mudahkan kamu nak bagi clear kamu nampak, jadikan P2 as your unknown. Perkara rumus, so bring it to the left hand side. That means P1 divided by T1 darab dengan T2. So P1 T2 divide by T1. Okay. So masa kamu nak darab tu, contohnya kalau kamu nak include this dalam calculator, make sure yang dalam kurungan tu is the one yang you solve first. Tapi ini darab dan bagi, so it doesn't really matter. Tapi kalau tambah dan tolak, make sure the ones in the kurungan, you solve that one first. P1. Okay, so this is the formula. So, kalau nak cari P2. So P1 darab T2 bagi dengan T1. So the answer is 1.71 atm. Okay, so that is how you derive the formulas from ideal gas law, ideal gas formula. Alright, next question. A sample of chlorine tetrachloride, CCl4 gas occupies a volume of 0.67 liter at a pressure of 1.5 atm. Determine the volume if the pressure is reduced to 0.4 atm at a constant temperature. So this is nampak lebih kurang sama macam kat atas tapi berbeza. Because kat sini the temperature is constant. So the rest which is P and V berubah. So dekat sini saya tak bagi tahu guna Boyle's law ke, Charles law ke, Gay-Lussac's law. Tapi saya bagi hint kat sini, the temperature is constant. So you don't, kalau kamu tak hafal, jenuh lah. Tapi kamu boleh derive. So for example, sama macam tadi. Apa yang constant? Saya dah lupa dah. Temperature is constant. So, apa nama? Everything that is constant, get it on the right hand side. Yang tak constant, duduk belah kiri. So here kita tahu temperature constant, so P and V berubah. So in this case, kamu dah tak perlu buat apa dah. So the first half of this apa nama non-ideal gas law punya formula is P and V. So P1 V1 equals to P2 V2. And dia suruh kita cari pressure ke volume. Determine the volume, the end volume. So V2 lah, dia suruh cari V2. So jadikan V2 as your unknown, your perkara rumus. So P1 V1 divide by P2. Divide by P2. So P1 V1 pressure 1 P1 is 1.5 darab dengan V1. So 1.5 darab dengan 0.67 liter and then divide by 0.4 atm. So the V2, the end volume is 2.51 liter. Okay. Next question. An unknown gas is introduced into an empty and sealed container with a pressure of 5 atm at 298 Kelvin. Determine the temperature of the gas if the pressure is reduced to 1 atm. So dekat sini berbeza dengan tadi, soalan nombor 3 ni saya bagi tahu apa yang constant. Tetapi in this question saya tak cakap apa yang constant. There is a way for you to determine apa yang constant. Kamu tengoklah apa yang berubah. So from the details yang kamu dapat kat sini, pressure, initial pressure is 5 atm, initial temperature is 298 Kelvin. The suruh determine the temperature of the gas, so that means the temperature changes. So temperature tak constant, pressure is reduced to 1 atm. So pressure also tak constant, pressure is reduced from 5 atm to 1 atm. So kalau pressure and temperature, P and T changes, yang tinggal adalah volume. Volume is constant. So you take PV equals to nRT. Oops. PV equals to nRT. You take the V to the right hand side and you take T to the left hand side. Sama macam tadi lah. Okay. So apa nama? P divided by T equals to NR. So on the left hand side is your first half of the formula yang kamu perlu guna. So P1 divided by T1 equals to P2 divided by T2. So this is the formula that you use. Dia suruh kamu cari, dia tu saya lah. Determine the temperature. So the T2, kamu perlu determine T2. So jadikan T2 as your unknown. So T2 equals to P1 T1. P1 darab justru kamu cari T2. Okay, my bad. So P2 equals to P2 times T1 divided by P1. Okay, so P2 darab P2 darab T1, P2 pressure 2. So 1 atm darab dengan 298 Kelvin bagi dengan 5 atm. So the answer is 59.6 Kelvin. Okay, so the trick here is, as I demonstrated to you, make sure gas tu obey law apa? Charles law ke, Gay-Lussac's law ke, Boyle's law. Kalau kamu macam mana nak tahu dia obey, kalau kamu tak tahu pun dia obey Charles ke, Boyle ke, Gay-Lussac's, make sure kamu tahu apa yang constant. Kalau kamu tahu property apa yang constant, pressure ke, volume ke, temperature, kamu boleh derive the formula to solve the problem from the ideal gas law formula. PV equals to nRT. So the first half of the formula is on the left hand side. So you bring everything yang tak constant, meaning everything yang berubah. Temperature is increased, so bring T to the left hand side. Kalau volume is increased, make sure it stays on the left hand side. Okay, everything yang constant letak di belah kanan. NR memang constant. Okay, confirm the constant. So yang berubah hanyalah PV and T. Alright. Next question. Question number 5. A balloon is filled up with Y amount of gas at room temperature until the size of a football. The balloon is then placed in a freezer at 0 degrees Celsius. After a while, the balloon is taken out and its size has shrunk to a tennis ball. So which gas law does it obey? So kamu ada balon, kamu tiup sebesar bola, football, bola sepak. Kamu masukkan balon tu dalam peti ais, and after a while you take it out, dia dah mengecut jadi sebesar biji bola tenis. So dia tanya kat sini, dia obey gas yang ada dalam balon tu, obey gas law apa? Boyle's law ke, Charles law ke, Gay-Lussac's law. So jawapan kat sini adalah Charles law. So how do you know? Kamu kena tahulah apa yang constant kat sini. So yang berubah adalah dia punya volume. Volume asalnya besar. Okay, volume isi padu. Macam mana saya tahu isi padu dia besar? Because asalnya sebesar saiz bola sepak, tapi in the end dia jadi besar bola tenis, dia mengecut. So the volume has shrunk, it is reduced. Apa lagi yang berubah? The temperature. Okay, asalnya gas tu ditiup masuk dalam balon at room temperature. Kemudian saya masukkan balon tu ke dalam peti ais. So the temperature is also reduced. So when temperature is reduced, volume will also reduce. It will decrease as the temperature is decreased. So yang constant kat sini adalah pressure. Pressure tak berubah. So kalau pressure tak berubah, maksudnya that gas obey Charles law. Alright. So sini nak tunjuk ada apa yang constant. Charles law, pressure constant. Gay-Lussac's law, volume constant. Boyle's law, pressure, volume, temperature constant. Okay, so macam mana kamu nak tahu which law dia obey? Cari apa yang constant. So kamu ingatlah Charles law apa yang constant, Gay-Lussac's law apa yang constant, Boyle's law apa yang constant. Newton gas law tu tidak wujud. Okay, I just made it up to confuse you. Next question, so refer to this diagram. The initial temperature of the gas is 40 degrees Celsius as stated here in the picture, and the volume is 20.5 liter. So the final temperature is 60 degrees Celsius. Determine the final volume. So the same as above, kamu tengoklah apa yang constant kat sini, use PV equals to nRT. So kita tahu temperature is changed, it is increased from 40 to 60 and volume is changed. It started at 20.5 liter and disuruh cari. So maksudnya it changes lah. So yang constant kat sini adalah pressure. So this obey. So masuklah apa nama pressure. PV equals to nRT, pressure bawa to the right hand side, VNT to the left hand side. So V1 T1 equals to V2 T2. So if you include all the details dalam the formula, jawapannya adalah 30.8 liter. Question 7 also refer to this diagram. Ada satu bekas before and after. Okay, bukan dua bekas ah. This picture on the left hand side, this drawing on the left hand side is the before. It's the before picture of the picture of the right hand side. So ada satu beaker, dalamnya ada gas, dan dekat atasnya ada piston. So bila piston naik ke atas, particles can move around freely. Tapi bila kita tolak this piston ke bawah, less space are available for the gas molecules to move around. So they akan bump onto the walls, onto the piston and to the bottom of the beaker a lot more frequently. And this akan hasilkan a higher pressure. So that's what I cakap, when you push down the piston, the volume will be decreased and the pressure will be increased. So the volume ni, kamu think of it as a space. Think of it as the space for molecules to move around. Okay, because the molecules of gases bergerak dengan bebas. It moves freely and randomly. So when there are a lot of space for them to move around, less pressure will be produced, will be exerted. Tetapi kalau kita reduce that volume, as you can see from the second the picture on the right hand side, so dia akan reduce, dia akan ada less space for it to move around, so dia akan bump around, dia akan bump on the wall, on the piston kat atas, kat dinding kat bawah dengan lebih banyak. So pressure is increased. So the question is, from the diagram above, choose the correct statement regarding the pressure of the gas. So pilih statement yang yang paling tepat mengenai situasi dekat atas ni. So if the pressure of the gas is increased, as I mentioned tadi, bila kita tekan dia ke bawah, volume is reduced, so the pressure is increased because the gas molecules bump on the piston, on the walls, and the bottom of the beaker more frequently. So tengok B punya option, the pressure of the gas remains the same, tak betul. Okay, and C, the pressure of the gas decrease, also tidak betul. Alright, so that's the concept. Kenapa tekanan boleh jadi tinggi kalau volume dikurangkan. So the questions from soalan nombor 6 ni, starting from nombor 6 dan seterusnya ni, saya nak kamu faham the concept. Kenapa bila kita kurangkan volume, temperature, pressure boleh jadi tinggi. Kenapa kalau saya naikkan temperature, pressure also boleh jadi tinggi. Okay, so when we change one of the properties of these gases, it will affect the rest. Kita naikkan temperature, volume and temperature will be affected. Probably one of them will be constant. Kalau closed system, one of them sajalah. Ketika sistem itu terbuka, maybe semuanya akan berubah. So next question, another diagram. So from the diagram above, choose the correct statement regarding the relationship between pressure and the temperature of gas. So the first diagram here, boleh nampak dalam this round bottom flask ada gas. Okay, ada gas kat dalam dia, masukkan dalam water bath and kita letak atas hot plate, tapi hot plate tak turn on. So there's a meter up here, there's a barometer untuk measure pressure, it is 0. So kalau kita panaskan this hot plate to medium, the temperature will rise up right in the middle. So the pressure increase. Tapi kalau kita panaskan lagi, it is on high, the pressure will be on maximum. So apakah conclusion yang kamu boleh buat? apakah kesimpulan kamu boleh buat tentang hubungan pressure, tekanan dan juga temperature. So as you can see, semakin tinggi temperature, semakin tinggi dia punya pressure. Asalnya tak panas, medium panas, paling panas, maximum panas. And the pressure here zero, right in the middle and maximum. So as the temperature is increased, the pressure will also increase. So the answer is A. The pressure of the gas increases the temperature. All right. Next question, question number 9. 7.5 dm cubic of carbon dioxide gas is prepared at 30 degrees Celsius and 0.987 atm. So using the ideal gas law, determine the volume of carbon dioxide at STP. So standard testing procedure. Sorry, standard conditions. My bad, sorry. So STP is standard temperature and pressure. Okay, I mentioned last week, kalau kita nak buat test, kalau kita nak exchange information dengan scientists from other places yang buat experiments, yang buat test the same as your test tapi on different conditions. Saya bagi contoh Alaska, the room temperature will be different than our room temperature dekat Malaysia. So kalau dia buat the same test, kalau kita nak exchange idea, nak exchange results, susah sedikit because kita punya conditions, environment tidak sama. So in order for us to exchange information, in order for scientists to exchange information better, kita mesti ada standard temperature and pressure. This is to permudahkan scientists from all over the world berkongsi idea. So kalau temperature tu temperature, room temperature, make sure saya buat dekat Malaysia ni, kalau saya buat 25 degree Celsius, dekat Alaska tu pun dia mesti buat the same experiment, dia mesti buat the same test pada 25 darjah Celsius juga. Kalau pressure yang saya buat dekat sini adalah 1 atm, dekat Alaska pun, dekat atas gunung tu pun dia mesti find a way to reduce the pressure to 1 atm. Okay. So here dia suruh cari volume of this gas at STP. So dia bagi pressure is 1 atm, temperature is 298, volume kamu ada 7.5 atm decimeter cubic, temperature kamu ada 30 degree Celsius, pressure also kamu ada 0.97 atm. So macam mana nak cari dia punya volume at STP? So to solve this problem, volume ini condition details ni, ini bukan pada STP, because pada STP the pressure is 1 atm, the temperature is 298 Kelvin. So kita tahu ini bukan STP because the pressure is the pressure is 0.987 atm. Walaupun kalau kamu kata kamu bundarkan menjadi satu, tapi that's not the case. Kamu tak boleh bundarkan. Kalau dia tak tulis satu, this is not standard pressure. So to solve this problem is kamu perlu guna the ideal gas law, PV equals to nRT, and determine the mole. Kamu perlu determine the mole of the carbon dioxide gas kat sini. Berapa dulu. So to solve this problem, mana whiteboard tadi. So PV equals to nRT. Saya dah masukkan dalam saya dah masuk kat sini dalam feedback box, tak perlu saya tulis. So use PV equals to nRT untuk cari the number of mole first. Okay, because the number of mole pada bukan STP is the same as the number of mole pada STP. Pressure and temperature tidak akan mengubah bilangan mole. Okay, so the bilangan mole pada apa-apa keadaan sekalipun sama dengan bilangan mole pada STP, pada standard testing procedure. Okay, kalau kamu buat test tu pada suhu 70 darjah Celsius, very hot. Bilangan mol dia 1.5 mol. Kalau kamu nak recreate the same test tapi pada suhu 30 darjah Celsius, the number of moles tidak akan berubah. Dia akan maintain 1.5 mol juga. So that's why kita perlu cari bilangan mol dulu in order for us to determine the volume at STP. Because sekarang this is not STP. So guna PV equals to nRT, cari bilangan mol, cari N. So kamu akan dapat this PV divide by RT. So P is 9.87, darab dengan V 7.5, divide dengan R 0.08205, saya silap tulis kat sini, darab dengan K 300K. Okay, kenapa? Remember, kamu mesti convert degree Celsius kepada Kelvin. So remember, nak convert kepada from degree Celsius to Kelvin, tambah dengan 273. Okay, so here sepatutnya 303. Saya tak apa kat sini. So 30 tambah 273 jadi 303 Kelvin. So kalau kamu solve this in a calculator, kamu akan dapat bilangan mol adalah 0.296 mol. So, untuk cari volume at STP, you just gantikan this number of value untuk bilangan mol dalam PV equals to nRT. So, write down PV equals to nRT, and disebabkan kamu nak solve for volume, jadikan volume as your unknown. So, V equals to nRT over P. So, kita tahu N here is, kita dah kira tadi, 0.296 mol, darab dengan R, which is a constant 0.08205, darab dengan temperature. So temperature at STP saya dah include kat sini, saya dah bagi 298 Kelvin. And kamu kena divide dengan pressure. Pressure at STP adalah 1. So you solve this in a calculator, kamu akan dapat the volume is 7.3 decimeter cubic. Okay, so this is the workflow yang kamu perlu kamu perlu go through before you can solve this problem. So kamu mesti faham what is the relationship antara volume, temperature and pressure, and juga the number of moles. Tengok apa yang berubah, apa yang tak berubah. In this case, semuanya berubah. Volume berubah, temperature berubah, pressure pun berubah. So my tip for you is, kalau kamu tengok ketiga ni, P, V and T berubah, automatically kamu guna ideal gas law. Guna PV equals to nRT. Tak payah nak derive cari Boyle's law ke, Charles law ke, Gay-Lussac's law. If you see all these three properties, pressure, volume and temperature changes, that means you need to solve the problem using ideal gas law. PV equals to nRT. Alright? So make sure you understand the flow and the concept. Otak nanti berserabut. Okay, next question. Question number 10. Banyak pula soalan saya buat. 12 je. Saya take 5 sekejap because soalannya panjang. Saya nak minum air sekejap. Alright. Okay, guys, I'm back. So we have just 3 more questions. I'll try to finish this as soon as I can, as fast as I can. Okay, so question number 10. So soalan 10, 11 dan 12 ni soalan apa nama? Soalan kebat lah, kemahiran berfikir. So it is important for you to know how to solve problems that include apa nama yang kamu perlu think critically. So for example, contohnya macam soalan ni, acetone, the chemical formula is C38H6O. Is a widely used nail polish remover. Okay, so a sample of liquid acetone is placed in a 3-liter flask. Kamu ada satu bekas. Bekas tu saiz dia adalah 3 liter. Dia boleh apa nama? Dia boleh diisi sebanyak 3 liter, liquid ke gas ke whatever. So kita masukkan liquid acetone sebanyak 3 liter dimasukkan dalam flask ni, and then kita vaporize the acetone. Kita panaskan dia to 95 degrees Celsius at 1.2 atm atmospheric pressure. So the vapor filling the flask at this temperature and pressure weighs 5.87 grams. So calculate the molar mass of the acetone. So how do we calculate the molar mass of the acetone? Kat sini kamu boleh apa nama guna PV equals to nRT. Kenapa saya nak kenapa saya kata guna PV equals to nRT? Because dalam this formula ada the number of moles. So if you remember from chapter 2, kita boleh determine the molar mass using the number of mole. Because kalau kamu ingat the relationship, number of moles equals to mass jisim bahagi dengan molar mass. So kalau kita nak cari molar mass, jadikan capital M tu sebagai perkara rumus, make it as your unknown. So bawa ke atas and bawa ke bawah. So mass divided by number of moles, excuse me. So from the question kita tahu dia suruh cari molar mass. Mass kita ada, number of mole kita tak ada, tapi kita boleh cari number of mole. So mass we are given 5.87. So 5.87 gram ini perlu dibagi dengan number of moles baru kita dapat dia punya molar mass. So how to do that? Gunalah PV equals to nRT. Pressure kita ada 1 atm, volume kita ada 3 liter. R is a constant 0.08205. Temperature kita ada 95. Tapi 95 ni perlu di-convert kepada Kelvin. So 95 plus dengan 273. Dapatlah kat sini saya dah include buat dalam calculation 368. So just fill in the blanks lah. P apa, V apa, R apa, T apa. So carilah carilah N. So bila saya buat calculation kat sini, N equals to 0.119 mole. So include this value dalam this formula, N equals to M over M. So jadikan M as perkara rumus. So mass 5.87 baginya 0.119. So the molar mass of acetone is 49.33 gram per mole. The answer is A. Alright, so kamu mesti nampak the connections, the relationship antara different different formulas to solve problems. Semuanya ada kaitan. Kalau ada number of moles dalam this formula, kamu boleh kaitkan dalam number of moles of another formula. Okay, this is basic algebra. Kita apply mathematics dalam nak solve this chemistry problem. Question 11. Okay, octane C8H18 is one of the hydrocarbons in gasoline. So on combustion, bila kita bakar octane, it produces carbon dioxide and water. So this is the chemical equation: C8H18 plus O2. C8H18 is octane plus O2 because bila kita nak bakar, we need oxygen. If you don't have oxygen, and combustion cannot happen. So C8H18 plus O2, they produces carbon dioxide, which is CO2, and water, H2O. So what you need to do is, dia suruh kamu balance this chemical equation. So as I mentioned dalam our introduction class for this chapter last week, I advise you to buat dua kolom, left and right. So on the left column, kamu count the number of atoms yang ada. So carbon ada berapa banyak, hydrogen ada berapa banyak, oxygen ada berapa banyak. And the right hand side pun buat the same thing. Calculate the number of carbon atoms on the right hand side ada berapa banyak, hydrogen ada berapa banyak, oxygen ada berapa banyak. Then try to samakan dia. Kalau left hand side carbon ada satu, right hand side ada dua, satu tu darabkan dengan dua. Okay, and kalau hydrogen belah kiri ada 5, belah kanan ada 10, 5 darabkan 2 dapatlah 10. Okay, so kamu perlu tambah nombor dekat bahagian depan chemical formula tu. So kat sini tak ada multiple choice, kamu perlu fill in this answer sheet here. Okay, so kamu tengok kat sini count the number of atoms on the left hand side and compare dekat right hand side. Sama ke tidak? Kalau tak sama, dia tak balance. So, kamu perlu balancekan dia, seimbangkan dia. Right? So the answer is 2C8H18 plus 25O2 produces 16CO2 H2O. Alright, that brings us to our last question. Question number 12, which is a continuation. Okay, kamu ada the same chemical equation, octane tadi. Kita bakar octane tu. So using the balanced chemical equation, calculate the number of moles of oxygen required to burn 1 gram of octane. So dia suruh kamu calculate the number of moles of oxygen yang diperlukan untuk bakar 1 gram octane. So dekat sini saya nak bagi kamu nampak the relationship antara stoichiometry dengan chemical equation. Okay, that's the purpose of kita equation. From chemical equation tu kita boleh predict the number of moles yang diperlukan untuk menghasilkan certain product. So for example, dalam this chemical equation kita tahu kita ada octane dan kita ada oxygen. Bila octane tu terbakar, dia akan menghasilkan carbon dioxide dan juga water. Tapi how many? What is the amount? Kita boleh calculate, kita boleh predict using chemical equation, using a balanced chemical equation. So that is why you need to know how to balance chemical equation, because from the balanced chemical equation kita boleh calculate the number of moles, the molar mass, the mass yang terlibat dalam chemical reaction tersebut. So kita dah tahu kalau kamu solve problem 11 ni, kamu boleh guna the balanced chemical equation, which is 2C8H18 plus 25O2 ni. So kamu tengok to the feedback box kat bawah ni, saya dah buat jalan kerja. So balance the chemical equation first, you will get this. So determine the number of moles of octane. So kita tahu kat sini nombor 2 kat depan ni, nombor 25 kat depan ni, nombor 16 ni dengan nombor 18 ni, ini represents the number of moles. So kalau nak baca ni, C8H18 ni adalah octane. So 2 kat depan ni maksudnya 2 moles of octane. 2 moles of octane will be reacting with 25 moles of oxygen, menghasilkan 16 moles of CO2 and 18 moles of H2O. This is this is in theory. Okay, in theory, using this chemical equation kita boleh tahu berapa mole yang akan ada. So kalau dia tanya soalan kat sini, kalau kita nak bakar 1 gram octane, berapa banyak oksigen yang diperlukan? Okay, kita boleh calculate the amount of oxygen using this balanced chemical equation. How? First, you need to determine the number of moles of octane first. Okay, dia akan bertindak balas seiring. Is that it? Kalau from this balanced chemical equation kita 2 mole akan bertindak balaskan 25. Okay, so kalau kamu ada from the number of grams tu kamu convert, tak cukup 2 mole. So number of oxygen also tidak akan the combustion cannot happen, because for the combustion to happen you need 2 moles of octane. So untuk semuanya berkait, there's a relationship. For this reaction, untuk menghasilkan 16 mole of CO2, you need 2 moles of octane and 25 moles of oxygen. Kalau kamu ada 1 mole of octane saja and 25 moles of oxygen, you cannot produce 60 moles of CO2. Okay, this is stoichiometry. Everything bertindak balas according to the proportion, according to the amount that is available. The amount here kita measure using the number of moles. Okay, so kalau dia kata kat sini, kalau kita nak burn 1 gram of octane, dia suruh calculate how many moles of oxygen gas required for this reaction to happen, untuk bakar 1 gram of octane. So kita boleh calculate ni using this balanced chemical equation. First, we need to determine the number of moles of octane. Macam mana kita nak determine? Kita convert this 1 gram kepada number of moles. Kita guna formula N equals to M over M. Okay, lowercase m kecil bagi M besar. Sini saya dah buat 1 gram. Okay, the mass is 1 gram because dalam soalan kat sini kita 1 gram octane. Kita nak tahu berapa banyak oksigen yang diperlukan untuk bakar 1 gram octane. So 1 gram lah here the mass. Divide by dia punya molar mass, saya dah tambah 12 darab dengan 8 because the atomic mass of, saya dah bagi kat sini dah. The molar mass of octane is 114.23. This is the molar mass of 1 mole of octane. Tetapi kat sini kita ada 2 mole. So kamu perlu darab dengan 2. 114.23 darab dengan 2, kamu akan dapat 228.46. So the number of moles adalah 1 bagi 228.46, dapatlah 4.4 darab 10 kuasa negatif 3. So this is the number of moles of octane. Okay, kita ada untuk cari number of moles of oxygen, kita boleh guna this number of moles of octane. So from the chemical equation, we know that it takes 2 moles of octane to react completely with 25 moles of water. Therefore, the mole ratio is of the reactant adalah 2 dengan 25. 2 ni adalah the mole of octane. Kamu tengok ada 2 nombor, ada nombor 2 kat depan. And 25 is the number of moles of oxygen. That's the ratio, 2 to 25. So kalau kita, this is in theory ya, remember this is theory. So kalau kita kalau kita dalam makmal sekarang, kamu dah calculate 1 gram of octane tu, the number of mole adalah 4.4 darab 10 kuasa negatif 3. So kamu boleh cari the number of mole of oxygen according to the ratio. Okay, so kalau 4.4 darab 10 kuasa negatif 3 ni bersamaan dengan 2. 25 mole ni apa dia? X, kita tak tahu. So using the ratio 2 to 25, the number of moles of octane can be determined kalau kita buat cross multiplication. So therefore, okay, number 4 kat sini, bullet point number 4, 2 over 25, the ratio jadi 2/25, saya jadikan dia as dia punya jadi pecahan. 2 bahagi 25 sama dengan 4.4 darab 10 kuasa negatif 3. So the ratio from the chemical equation 2 bahagi dengan 25 sama dengan 4.4, the ratio yang kita nak situasi yang kita nak cari. Okay, so kita tahu the number of moles of octane is 4.4 darab 10 kuasa negatif 3 divide by X. Kita tak tahu, X is number of moles of oxygen. So jadikan X tu sebagai perkara rumus. So kita dapatlah jawapan 4.4 darab 10 kuasa negatif 3 bahagi dengan 2 darab dengan 25. Dapatlah jawapannya 5.5 darab 10 kuasa negatif 2 mole. And lastly, don't forget the units. So the reason why I put this, I include this question, because they can assess your understanding of stoichiometry. Apakah itu stoichiometry? They also assess whether can you balance a chemical equation or not. And from the balancing of the chemical equation and stoichiometry, can you solve this problem? Using apa nama, kalau kamu ada macam bagi kat sini, kalau nak burn 1 gram. So kalau saya ubah, saya tambah follow up question. Kalau kita nak bakar 2 gram of octane, so how many moles of oxygen? Kita tahu 1 moles of oxygen, 1 gram of, kalau nak bakar 1 gram oxygen, kita perlukan 5.5 darab 10 kuasa negatif 2. Kalau nak bakar 2 gram of octane, maknanya 2 kali ganda lah. So kamu just multiply this with 2. 5.5 darab 10 kuasa negatif 2 darab dengan 2. That's it. It is all in ratio according to the balance chemical equation. So katakanlah kalau kamu salah balance. Kalau kamu salah balance and you solve dekat bahagian depan ni betul, kamu cari ratio dia 2, 25 semua betul. Tapi kalau kamu salah balance, katakanlah sepatutnya 2 dengan 25, kamu tulis kat sini kamu balance 3 dengan 25. So all your calculations seterusnya tu semuanya akan salah. So make sure your fundamentals are kukuh, are strong. Make sure you know how to balance chemical equation. Okay, so that's it for gases.